Separate squares part 1. We are given a 2D integer squares. Every square is represented by 3 elements xy, xi, yi and l. So here it represents a square. Square needs two things: the point, the bottom left point is mentioned, and the length. So since this is a square, the side lengths will be equal. So L and xi, yi, and this is what is represented in squares. We have a couple of squares in the array, and we are told that we want to find the minimum y coordinate. So these squares are distributed in a quadrant, and we have couple of squares. We want something of a some y coordinate is what we want, that is minimum, and it divides into two equal halves the area. So this area and negative. Suppose if we consider it as positive negative, this will sum up to be 0, right? So equally divided areas, and if we have a overlap squares, something like this, in that case we can see that the overlapped square is also counted separately in terms of area, and that's why the y coordinate is shifted above instead of being the middle y coordinate, right? So essentially we want the minimum y coordinate, and if we look at the range is very high. 0 to 10 power 9 is what y is ranging from, and that's why what we can do, this already hints towards binary search, but there is a couple of issues. So if we perform a binary search, uh, ranging from 0 to 1e9, so if we perform a binary search, in that case we fix a middle point, check its validity. How will we check its validity? This midpoint is what it's representing a y coordinate, right? So if it's a valid point, then this must divide the area equally. So we can traverse through squares and the O of n operation, get the area, get the balanced area, like I said, positive, negative, and if it's equal to 0, if balanced area is equal to 0, then take it as answer and go left because we want to minimize. If balanced area actually if it's a 0, then it's the answer, right? But we will come back to this. If it's greater than 0, then above area is more, then we want to shift or minimize the positive area by shifting up, that is going high in the y coordinate range, going right is what we need to do. Go right. If balanced area is less than 0, then go left. But the problem is we can do all of this and this will work just fine if we had only integers that we were dealing with, but here we are dealing with floating points, and that's the reason we need to do a binary search such that we still respect the boundaries, but also go get the minimum, right? How can we do that? If we had integers, then what we were doing is we had a while loop, we checked the validity, midpoint, go left, go right here inside this, and we had something like this. We used to have something like start is less than equal to end, right, as our exit condition or something like that. what we can do here is end minus start is less than or greater than epsilon, or something like e minus 5, right? Because this is the acceptable answer, and hence we are going to continue as long as it's greater than this epsilon, right? If it's greater, then we don't have an answer yet. If it's not, then we have an answer yet. In that case, here we need to modify something. If balance area is equal to 0, instead of this we should have something like, if it's less than 1e minus 5, right? If it's anywhere in between this range, in that case it's a valid answer. Then don't just take the answer, but also go left in order to minimize, right? And that's it. If we follow these points, we're going to solve this problem. So we have a start. Mind that we are taking it as double for reasons that are already told here, right? So initially it will be integer, but in the binary search this can turn floating point. My bad. Let's have an end. The end range will be 1e9. This way is going to continue. End minus start is greater than 1e minus 5. We fix the middle, since things can go over, things can overflow because start and end can be pretty large as 1e9. That's why we do the middle point, we extract the middle point using this, so that things are within the range. Balanced areas with what we want. Area is equal to get balanced area. Let's have a function. It will take squares, and middle, if the balanced area is having absolute value, we are taking absolute value because it can be within range but negative, right? In that case also this should be valid. So as long as if this is below, in that case we have the answer, but we are not going to break here, we are just going to continue. If balanced area is greater than 0, then we are going to go right, and going right means taking start to middle, else taking end to middle, right? And finally return end or start, anything is fine. So we have this to implement. This is going to return an area that's going to be double. It's going to take squares. So let me copy this, and it's going to take a middle point, which I'm going to call y coordinate, or just y is fine. So let's have an answer. Initially 0.0. I'm going to iterate through squares. Every square is going to give me the height, and that height will be represented by 2 points. One point will be y1, that's the middle or the bottom line, y1, that's going to be represented as square 1. Similarly, y2 is going to be represented as square 2, square 1 plus square 2, because that's the side length. Now we have 3 scenarios: square entirely entirely above y, square entirely below y cutting square. Right, straightforward. You get the idea. If the square is entirely above, that means the bottom line of the square, that is y1, is greater than equal to y. y1 is greater than equal to y. In that case, I am going to increment the area because it lies above, and the area will be square 2 into square 2, right? Otherwise, if it's below, then that means the above the top line of the square, that is y1, or sorry, y2, is less than equal to y. In that case, I'm going to do the same thing, but this time subtract the area. Else, I'm going to increment and decrement. So area plus equal to increment what? y1. So if you want the idea, if this is y, this is the scenario that is going to be representing this condition. Uh, this is y1, y2. Then this area will be positive, this area will be negative, positive, and this area will be what? Side length will be L, this will be y2 minus y, this will be y minus y1, right? So y2 minus y is going to be incremented into square 2, and the same thing is going to happen here. Alright, this time y minus y1, and this time it's going to be decremented. And lastly, I'm going to return area. That's it. Let's run it and see if it works. This should be squares. Alright, so squares. Oh sorry, let me make this area. Okay, square, 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 right? Spelling mistakes. Alright, this works. Let's submit it. Time complexity will be binary search. So that's login operation. Okay, this will overflow. I should have taken care of this. Let's make sure that doesn't happen. This also might overflow. This shouldn't overflow, but just let's be safe and let's submit it. Alright, this works. Time complexity will be O of n log n, because this binary search is a log n operation, and for every midpoint we are going to do a log n, n operation, so that's going to take our time complexity to O of n log n. So that's the problem. Thanks.